Welcome again to the Expert Briefing Series. I am Conrad, one of the co-chairs of this year's PyData Global Conference. We have Marco here to talk to us about NLP.
All right, thank you for the introduction, and thank you all for joining the session. I hope you are enjoying this first couple of days of PyData Global, and hopefully the conference, the main event coming up next week will also be very nice. So the presentation will be roughly 15 minutes. The title, Natural Language Processing, Trends, Challenges, and Opportunities. When we started talking about doing this kind of sessions, we were thinking in terms of catching up with the state of the art, but I like the idea of just talking about where we're going with the field and what people are struggling on and where we can go essentially. So more broader and hopefully relaxed discussion. So after the presentation, your input will be very much appreciated. Any kind of question or comment. I have a few talking points. If nobody has any burning question, I can ask you some questions, and maybe you'll tell me your views on natural language processing. That's a picture of me in my better days. I work as a data science consultant in the Python and data space, and I do a lot of training and coaching also in the Python space, pandas, scikit-learn, and whatnot. Apart from work, I am an organizer of the PyData London chapter together with Conrad. And I've been chairing the past couple of editions of our annual conference. We have an annual conference and a monthly meetup. Everything, of course, now is on hold. Hopefully, we will have the chance to resume everything soon. Before becoming a data science consultant, I spent some time in academia. My background is information retrieval. That's where my interest for natural language processing is coming from. I was developing at the time sort of semantic search engines. Before that, I was a software engineer for a few years, and that's kind of 20 years summarized in a sentence. Now, enough about me. Let's talk about natural language processing now. Now, my assumption here is that you simply have some interest in natural language processing. If you're here, we don't assume anything in terms of expertise. Some of you are learning, some of you maybe are using NLP already. Some of you are simply curious to see what is going on with NLP. And why is NLP interesting? Why is it important? Well, when you break it down, there are sort of two sides of the story: the what we call natural language understanding, or NLU, and natural language generation, or NLG. But besides the all the acronyms that you might find, essentially what we are trying to do is we want to understand the language and we want to produce language, kind of like we do as humans. So that's the overall idea with NLP, and the applications are countless. So you can see already why this is an interesting field. It's also a challenging field. Let me give you just one example. If you get this sentence, how do you extrapolate any meaning out of this? And that's proper English. I'm not joking. That's proper English. That is that, and I'll just give up. I guess it's kind of difficult to parse. Now, the trick here is that I left out the punctuation. Once you put it in, is actually a reference to some of the old philosophers from back in the days. And you can find a lot of this kind of linguistic examples, linguistic situations where it's kind of difficult to parse. Going beyond this simple example of why is this challenging, let me give you an example about ambiguity. They ate pizza with anchovies, and you can see from the picture there are two possible interpretations here. This one in particular is what we call a syntactic ambiguity. Essentially, you can read the sentence in two different ways. And maybe a person would have some kind of common sense and understand the context. But from a computer perspective, from a an algorithmic perspective, this is still a relatively difficult challenge to sort out at large. We also have ambiguities at the word level, so the same word maybe can have multiple interpretations, and again, context could be relevant here to understand. So the summary is that language is challenging. Why is it challenging? We saw a couple of examples, but something to consider is that, first of all, language is evolving. And often in NLP, we use maybe data sets that are in the public domain, but they were produced, they were curated 20, 30 years ago. Are they still relevant? Well, that's to be something to consider. Language is ambiguous, as we seen in a couple of examples earlier. We have ambiguity at the word level, at the syntactic level, and context is what we need. So to understand language, we need context, we need some kind of common sense applied as well. So long story short, language is challenging. And in order to tackle challenging language problems, typically we need data to support our algorithms, and more precisely, we need annotated data. Now, the problem with annotated data, we can find annotated data, but there is a lot going on in the space that goes beyond what is our specific domain. So variability of the language is also to consider. Often maybe we use a data set of I don't know, newswire articles from 20 years ago, as I mentioned. Is our business domain newswire articles? Is there anything that happened in the past 20 years that maybe is not reflected in the language? Are we using a language that is not English? So all these variables are to be considered. So for this reason, I say available data, at least kind of in the public domain, tends to be sparse. Sparse as in there's a lot of data, but data that is high quality and good for our specific domain, for our specific task, for our specific language is a bit more sparse. So that's one of the issues. And also more recently, probably in the past 5 years or so, we've been discovering more and more about bias in the data. We often treat annotated data as the golden truth or the ground truth, but somebody did the annotation, so naturally we will have bias in the data itself. And as I said, we've been talking a bit more in the past 5 years or so, in parallel with the sort of the whole field of data science growing up and realizing that there is a whole branch of ethical implications in what we do. And NLP is also following the same pattern with workshops dedicated to the topic. Annotated data is also, I call it a bottleneck, essentially still expensive, still takes a lot of time and effort to do. So even though for if you need to come up with an idea for a side project, you will find something easily in the public domain. Once you need to solve a specific problem in a specific domain, in a specific language, things are not always so easy to get. I've been talking about a couple of challenges here. Let's talk about how the field has evolved in a minute or so. So I will give you a very incomplete history of NLP in 3 bullet points. 3 bullet points because we essentially talk about 3 different families of approaches. First of all, in parallel with the first efforts in the AI space at large, we can talk about symbolic NLP or rule-based NLP. A lot of work that goes kind of long before the 50s, but I put the 1950s as a starting point because that's when a lot of work started to happen. At the time, linguistics as a field was also kind of a bit more involved. A lot of ideas were developed from linguistics, and the people were trying to bring them towards the algorithmic side. Fast forward a few decades later, in the 90s, we have seen the rise of different machine learning approaches and a more statistical approach towards NLP as well. So the use of annotated data in NLP and extracting statistics from annotated data. And we can disagree on the exact days here, but roughly at some point in the 90s, that's where things started to pick up. And we stayed there for a little while until the past decades, let's say from 2010 or so, when we've seen the rise of a lot of deep learning approaches in a lot of different fields. NLP came maybe a little bit later compared to other fields, but these days, a lot of what is happening in terms of the latest R&D is also happening in the deep learning space. So just 3 bullet points to give you the history, because essentially here we have the summary of what kind of models are used in NLP. And as we see this kind of evolution from rule-based to statistical and machine learning type of models to deep learning type of models, essentially we can look at how we have been evolving in terms of data representation and the application of specific algorithms. From the data representation point of view, for many, many years, we've been doing bag of words. There are references of the phrase bag of words already in the 50s. And it's been used quite a while, the whole feature engineering story with the more traditional machine learning approaches. More recently, I put 2013. Again, we can disagree on the dates, but I put 2013 as a reference to the Word2Vec paper that triggered a lot of further research. There's been a move towards a representation based on word embeddings. That's not when word embeddings have been invented. We had references to some of the ideas also in the previous decades, but that's probably when kind of everybody started talking about word embeddings, or in the following couple of years, 2014, 2015, both from a research point of view and also from a more practical point of view, with libraries supporting word embeddings in a way that is relatively easy to use. So with word embeddings, we've been moving from from representing data with a bag of words towards representing data as vectors that capture semantics, similarity between concepts, and the whole story of compositionality. So maybe if you have seen a previous presentation on Word2Vec, you're familiar with the king minus man plus woman equal queen type of example. So that's for the data representation. On the algorithmic side, well, it depends on the task, but let's say we've been shifting from let me call them traditional machine learning models, whatever traditional means. I'm not a big fan of the terminology, so I put it in double quotes, but you will find often this as a reference. So old school machine learning models, and then around 2015-ish, we have seen a lot of examples of recurrent neural networks and long short-term memory networks being applied. Again, we can disagree on the exact date. Here, I'm just referencing some of the products from Google. I don't remember if it's Google Translate or other that were pushed a lot around that date. LSTM per se goes back to the mid-90s as a proposal, at least. But nobody was really using it for NLP at large, so it became very, very popular around those days. And from there, a couple of years later, we have seen the rise of the Transformers family of models. I put 2017 as a reference to the Attention is All You Need paper, and then probably 2018, 2019 is really when everything took off. And these days, in terms of research, at least the state of the art seems to be moving towards a different flavor of transformers architecture. Then the question for me is whether, you know, is everybody using it, or is everybody talking about those type of models? So that's the summary of the evolution of the models. And since I should be touched on the state of the art, I should also mention the dedicated slide to the transformers architecture. So it's kind of difficult to summarize in a slide. So I just give you a couple of points of why transformers became so popular. So a couple of things that they brought to the table is, first of all, the option for parallelization. So data didn't need to be processed sequentially anymore. So opening the door for parallelization means we have seen the opportunity to train on bigger and bigger data sets. So kind of cutting the training time, or potentially having the same training time, but on a much bigger data set. In parallel to this idea of parallelization, we have seen also the opportunity to fine-tune on a specific task. So often these kind of architectures, they are pre-trained on a generic data set, could be Wikipedia, or it could be something general purpose. And then they have the option of fine-tuning for the specific task for your specific domain with a smaller set of annotated data. So this is the main 2 points that I guess as a family of architectures the transformers have brought to the table. So as a tendency that we have seen as a result of having transformers available now, we see bigger and bigger models being pushed. So when you look at the leaderboard type of tables on the state of the art for different tasks, at least when you try to catch up with the academic literature, you will find bigger and bigger models being released. And also more and more pre-trained models being released. So a lot of the big names, Google and Facebook and whatnot, they release their models as a pre-trained kind of open source, in a way, the pre-trained model that you can download and reuse locally. We've seen this with Word2Vec from 2013, and at the time, I guess it was not so common to release a pre-trained model in a kind of in a binary format that you just download and you can reuse. But in recent years, we have seen a lot more of this. Now, I mentioned 2017 as a starting point of when the transformers started to take off with the reference to the Attention Is All You Need paper, and I want to point out that paper triggered a lot of additional work. So there's 29,000 citations, at least this afternoon. So 29,000 other papers that cite the Attention Is All You Need one, meaning a lot of work has been happening in the field. And to be honest, I haven't read 29,000 papers. So when we spoke about let's talk about the state of the art in different fields, it's kind of difficult to catch up these days because there are so many new pieces of research coming out in the field that is really, really difficult to stay up to date. Earlier this year, I came across this nice diagram. That's the link at the bottom from a research group of a university in Beijing, where they try to map some of these architectures. There's BERT and GPT that you might have heard of if you keep an eye on what's going on with NLP, and then many, many more. And this is just a tiny picture, taken from those 29,000 citations. There's quite a few different models going on here, as you can see. So the space is becoming very crowded and is evolving very rapidly. So it's very difficult to catch up. There's also another direction that people are starting to consider. Earlier this year, there was an interesting paper, a kind of a positional paper, if you want, that challenges this idea. And they call this type of pre-trained models or sort of large-scale language models that we're seeing these days stochastic parrots. There's been a bit of a misunderstanding of what these big language models are. Some people talk about them as if artificial general intelligence is a problem that we have now solved. Some people reference this as parrots, so they can simply repeat what they see in the data, and they do so in a way that is often quite interesting, useful, and surprising. But that's what they are. They're language models, so they give you a probability of a string based on the training data, and then it can be as sophisticated as we want. But that's what they are. And the question they ask in this paper is, are these models too big? So is this really the best direction for the field? And they list quite a few points. For example, the financial cost of this type of models, also the environmental impact of training this huge model and doing research in this direction, and a few other points that is worth considering. So a nice reference to check out as well. Before closing the presentation and opening the floor for a discussion, I also want to mention the Python NLP ecosystem. So back in the days, there was only NLTK, which is roughly 20 years old. And then over time, luckily, other tools came up, and they're doing well. They're easy to use. They're nice. They offer a nice interface. They offer a lot of support for a lot of existing algorithms. I want to mention scikit-learn because even though it's a general purpose machine learning library, they do have some components that are useful for NLP. GenSim became very, very popular when they implemented the Word2Vec version in Python, and at the time it was actually faster than the original C implementation from Google, so they made a lot of noise around I guess 2014 or so. SpaCy was born also a few years ago. General purpose library. They offer a lot of options for a lot of different tasks, and then something a bit more specialized, Rasa, if you're developing conversational agents. Rasa seems to be one of the go-to tools these days. And finally, Hugging Face as a hub for the Transformers library. They have a Transformers library, they have a dataset library, and they work as a company. They are essentially a hub where they offer access to this kind of pre-trained models, and they have a lot going on the NLP side. There's probably many more libraries to mention here, but these are sort of the big names that you will find in the field. Okay, that was a quick intro. That's essentially the end of the presentation. Now we're going to open the floor for a bit of a discussion. Just want to mention on my website, my fullname.com, you'll have references to all my previous presentations about NLP and all other topics. I also run a newsletter about Python and data, and then the usual social media thing if you are so inclined. So that's all on my side. Let me stop the screen share, and we can open the floor for the discussion. So I'm happy to take questions. You can either type it in the chat or sort of raise your hand and ask away. I'm going to paste also some links in the chat. I have the slides for the presentation. I have my contacts, and I have a reference to my upcoming trainings as well in December on pandas and NLP. So you will get all the links in one place. I have some talking points if nobody asks a question. Okay, something popping up. Okay, and he's asking, so wants to get started with NLP, maybe perhaps a simple classifier out of all the options. Where's a good place to get started? Imagine they want a first useful solution before worrying about the state of the art. Yeah, the first useful solution. One of my talking points actually is when we implement natural language processing solutions, is it really different from any kind of data science problem, or is it just kind of a specific area of data science, but we should sort of follow the wisdom that hopefully we have from designing data science solutions and deploying data science solutions. So the good starting point is to have the simplest possible baseline that works end to end, and then iterate and improve from there. And in terms of simple baseline for NLP, I guess what we called earlier traditional machine learning approaches, support vector machines, often seen for many years as state of the art in text classification. If you want a classifier to start with, or really any classifier would make a good baseline. In that case, you still need to consider the feature engineering aspect. So for feature engineering, what we know from traditional NLP courses and information retrieval courses about bag of words, about TF-IDF, those kind of concepts that have been around for a while. That's what I would consider a solid baseline, a good starting point. And you have the benefit of explainability, sort of easy to understand, easy to debug before moving towards more complex systems or solutions. All right, let me catch up with the chat. Zeti says, thank you for sharing, thank you for attending. Can you share your view about NLP on non-English foreign languages? Yes, the amount of data for language in general is growing rapidly, and the amount of data for non-English language is growing very rapidly. Let me say today is better than 5 years ago in terms of availability of data. We have, at the very least, we have people asking this question, which is a good starting point. Oftentimes we kind of default to English. Also in research, we default to English as the main English, the main language, but there's a lot going on in terms of data being available and annotated data in particular for foreign languages. I don't have probably a, if you ask me for this particular language, what do I do? I don't have an answer for everything, but good places to check out are typically Wikipedia, that is often available in so the same articles are available in several languages. For European languages, there's the transcripts of the European Parliament. There's a little bit more also for French from the Canadian Parliament. They do side-by-side English to French, like the European Parliament. They do side-by-side English to French to German to all the other official languages. Yeah, at least there is some awareness of the fact that there are more languages than English, and that people want to do NLP on more languages. So we start seeing more resources available. What books would you, Matteo is asking, what books would you suggest as good general references for NLP? There's many books, to be honest, that we could think of. Let me just see if they are actually available for free. There's something on the academic side, if you are interested on the algorithmic aspect of it, more on the theory side. And for NLP, there's foundations of natural language processing by Manning and Schutz. So I think it's you can read it online. I don't know if there's also a PDF. So let me put the link in the chat. Foundations of NLP of statistical NLP. So link in the chat for the Foundations of Statistical NLP book. It's probably 20 years old. So it focuses on statistical NLP. Doesn't necessarily have the latest state of the art, but a lot of ideas here are really useful and still applicable these days. If you want something more recent and more on the deep learning side, I found the I don't have it here, the Deep Learning with Python by François Chollet, who's the author of Keras, to have some good material also on NLP. So Deep Learning with Python by François Chollet is published by Manning, so I don't think you will find it free online unless you have like Safari or one of those subscriptions. I can mention another 20, but probably 2 is a good starting point. NLTK also have the NLTK book, good for learning, sort of general introduction, but it's a little bit less modern, I would say. These days, people tend to use maybe Spacey a bit more in the, at least in the industry, as a go-to library. But they do have the book for free, so you might check that one as well. nltk.org. Then I don't know if it's slash, sorry, nltk.org. Well, don't know why it goes on a new line on my screen. Okay, I hope I gave you the answer. Let me catch up. Oh, that's a question. What do you use to for the interpretation of transformers? That's a challenging one. That's ongoing research. So one of the criticism for people who are not into deep learning research in general is the fact that often it feels like these models are simply black box models and we don't know what's going on the inside. I think we're not there yet. So interpretability of transformers at large is still an ongoing area of research. So oftentimes we kind of have to experiment with our own data. So you pull a pre-trained model and you see how it behaves with some kind of cherry-picked examples on your data. I don't have a specific experience on doing something a bit more formal, like you could do with more traditional models here. Yeah, it's an open question, at least for me. And if anybody has experience in this direction, you're also welcome to contribute. Okay, let me then ask you a question. For those of you who use NLP, who are NLP practitioners, what do you use it for? And what is it that you find more challenges? So what are your biggest sort of pain points when you try to implement an NLP solution? And you can tell us if you are more of a specialist or a data scientist who doesn't have an NLP background but has to work on NLP problems maybe. So what do people work on if you do work on NLP? Do you have any example of a project that you would like to mention? Anything that was challenging?
So I think for me, from like the perspective of not a professional like NLP person at all, right? The challenging part is to I think especially for some of the earlier models, you know, like the Word2Vec or like stuff that like it's easier to wrap your head around. like that stuff is okay, fine. Like it's like easy to do. I can try to like work through this myself and do it. But then so you get from like 0 to like maybe 90% of the thing working. But to get from like 90% to like 95 or 99 and like fine tuning that extra model, it's just like suddenly like you go from like, oh, this is like manageable to like, oh, I'm way out of my depth and I have no clue what's happening for the as you said, the transformed models and like that's some of the more complicated stuff. So for me as a
So are you talking about like improving the quality of what you have, or are you talking about the switching from a baseline to a more state-of-the-art type of model?
So improving what I have, which is basically either knowing how to tweak it, or like maybe you want to like use a more state-of-the-art model, both of which are I feel like I do not have any expertise in.
And that's why we have data scientists, right? It's an ongoing process. Typically, it's not a one-off thing. Just like tackling any data science problem. Here we simply have a language type of data, but you want to have some kind of baseline early on, so you can start doing some error analysis, looking at what goes wrong. Something that people often don't consider also is, did you talk to the business domain experts? Maybe they can tell you a bit more about your data and why you see what you see and what are the expectations. So as a data scientist, we have the tendency of jumping into, sorting out a problem with an algorithmic approach, but often the understanding of the underlying business and why do we have the data that look the way they look, and all those kind of questions, they need to be asked essentially. And then it's a matter of trying to understand whether you mentioned 90%, let's say if it's 90% quality, is that good enough? And the price to go from 90 to 95, is it really worth paying that price? So often there's a lot of effort going on for just a marginal improvement, a tiny improvement. So I would say that's not necessarily an NLP only problem. It's a broader data science type of problem. Then talking about switching from the more traditional, more baseline-like type of models to the more advanced ones, there's a lot of complexity going on, and it took me a while to kind of understand what is going on with the transformers architecture. My suggestion is, if you really want to fully understand what is going on there, you need to look at the papers, you need to look at the research papers and get your hands dirty with the sort of linear algebra or whatever it is going on in different models and see what they bring to the table. I rarely have the need to be really on top of the very latest thing that is happening. So I have the luxury often of I can wait a little bit for all the buzz to calm down, so more accessible resources pop up, blogs and YouTube videos and whatnot that are available. So there's a few different resources in simpler formats, simpler as in not using academic language like a scientific paper, that are more layperson type of language. For example, there's like an illustrated transformer blog post that was popular a couple of years ago. And then there was a narrated transformer, which was the YouTube version of it. So those kind of things tend to pop up a couple of years after the main research paper is presented. So there are options if you start looking into it, but bottom line, if you really want to understand the details, you need to look at the original research papers. That at least I learned more about the transformers architecture reading the research paper than reading 20 blog posts that were just repeating the same kind of high-level ideas. So that's at least my experience so far. So you need to kind of get comfortable with that level of math. And if that's not something that comes easily to you, you bring it to a local data science journal club or something. We have those type of meetups where people bring an academic reference and then you discuss it together. That's also an option, asking for help in those kind of circles. We had Lev running one in London a couple of years back. So that would be my suggestion. Okay, let's see. So on the chat, my domain is finance. The main challenge is capturing domain-specific context. Yeah, often the financial corpus is too small or too expensive, annotated by experts. So I spend most of my time on data gathering, annotation, performance accuracy on general corpus may not be the same on specific corpus. Yes, you are describing a common issue. We have a lot of this general purpose English, newswire English data available out there. And there is a good chance that our business domain is not newswire general purpose English. So yeah, that's what we said. Annotation is still the bottleneck. Talking to the experts, still something that you have to do, still expensive, time consuming, and everything that we know already. And I don't think there's a magic solution here. Simply we kind of have to do it. When some guy a few years ago said data is the new oil, sounded a bit fluffy maybe at the time, but that's what is happening. So your data, your business domain, your expertise, and the expertise of your peers will be important for your domain. So I see the pre-trained models on Wikipedia and whatnot just as a starting point to start playing with the tools to have a flavor of the APIs and whatnot. But then if you have an actual problem to solve, you will have to bring your data into the discussion. Right. Yeah. Any other question or talking point or comment from anybody?
Yeah, I may try. If you can hear me,
please.
guys.
Yeah.
Hi, Marco.
Hi there.
Thank you for your answer on the question on for your talk first, and your question on interpreting transformers. I've been working for the past year on NLP. My recent developer converted to data science. And,
excellent choice.
Yes, yeah, absolutely. I didn't get bored at all. Yeah, I really love it. And yeah, I find it was great to work on NLP because there's so many. It's so mature. Maybe compared, I think compared, for example, to computer vision, because in NLP you have those great libraries like Spacey or Hugging Face, or the one you mentioned, like NLP Sim, that enable you to build things so quickly. And yeah, the question you were, what do you use it for? But to me, it's basically to build classifier, but and instead of using like tabular data, you use full text. And yeah, for interpretation, I was asking because I just starting to look into this, like looking at Chap or Lime. It's not really satisfying, is it? Like Lime, you would be doing analysis only on a single token level. Ideally, you'd like to be able to, you have a classifier and you have a piece of text and you want to say, okay, this is this sentence in the full text, which contributed highly into making that prediction. And yeah, I'm trying to find if that's doable, but yeah, it's a hard one.
No, it is hard. The tools that you mentioned, and there's several others available. There was a talk. Let me look it up briefly. Yeah, there it is. I'm gonna put a YouTube link on the chat as well. This one was a talk given at PyData London at the meetup by Dean Alsop, I think, where he went through a lot of different tools for explaining machine learning models. So it's not specific for NLP, but it gives you a nice overview on explainable machine learning. Yeah, the work on the deep learning side, I would say it's ongoing. So all those tools, they tend to be more on the more traditional sort of feature engineering side of things. They can be helpful for that. So I agree, it can be a little bit frustrating at times, and it's definitely not a solved problem. The YouTube link is pointing to that talk. I also want to point out, in case you're new to PyData, all the PyData talks, at least from the past few years, from different conferences, different meetups, they end up on the PyData YouTube channel. So there's countless hours of entertainment on YouTube for you if you are so inclined.
Yeah, thank you for sharing it.
You mentioned classification. What's the, if you can tell us, what's the use case? What are you classifying? Is it topic?
Of course. Yeah, so I've done a bit of topic modeling, so to basically explore your data. And I found, and I mean, and then I've done some classification to classify on tasks. So I'm doing research basically as a freelance for a company who build an AI product for insurances. And basically the aim is to automatically classify claims from people, like I had an issue, my TV got broken, my cat has been running around in the living room, got crazy, pushed the TV, fell on the floor, and now it has cracks and doesn't turn on anymore. And basically we want to understand, yeah, who did that, why, is it broken, what type of damage it has. And this is why we build like classifiers. We worked also on outlier detection. I mean, there's so many different things you can do there, right? And one question I often ask urban NLP is, when do you now use machine learning models? Because anytime I try deep learning models, I always get top performance. I mean, it's clearly the state of the art. And now even with like larger models, or which, by the way, I'm very interested to read the paper you mentioned about like the parrot issue.
Mm-hmm.
But I mean, even now you can, with natural language inference, with zero few shots learning, you can create model. Thanks to large pre-trained model, you can create models with little amount of data. So in which circumstances do you happen to use, like, to get back to, apart from doing a baseline, do you end with model in production that use, for example, TF-IDF and logistic regression or something like this?
Yeah. Why not? You know, if it works, why not? As a rule of thumb, and we can disagree on the numbers here, if I have less than 5,000 documents, then, you know, what does it mean? Are we talking about tweets, or are we talking about long Wikipedia articles? So the size of a data set is not just the number of documents, but also number of words and all that stuff. But if you want a number, my starting point would be less than 5,000 documents. I wouldn't even look at any deep learning approach. I would expect those approaches to simply pick up noise. Maybe they work well in some setting, but maybe they will not work well on you know, on the data that you get in the wild. So that would be my personal rule of thumb. If you don't have a lot of data, don't bother. Essentially, go with the traditional bag of word and traditional
word embedding even.
Logistic regressions and so on. For word embeddings, it depends on the total number of words. I would say if you have at least 100,000 words, so the count of all the words, you will start seeing some of the similarities between concepts being captured by the embeddings, but just about. If you have more than 1 million words, then definitely you will see the similarities and those relationships, you know, king minus man plus woman equal queen, those kind of things will pop up. So I would say 1 million words is probably, as a rule of thumb, a good starting point. 1 million words is not a big data set. It's 1,000 documents with 1,000 words each, roughly. So word embeddings, at least for an exploratory data analysis exercise, I would check them out, see if in fact, with a client, we did something like that. We had a simple logistic regression classifier in production, and then we did a word2vec thing with a nice dashboard to visualize which concepts were close to each other. It didn't end up in production, but it was very, very useful to learn about the data. So you can still check it out, you know, as a prototype. Why not?
Yeah, it's also what I usually do as a baseline to build something very, very quickly. I wonder, what have you ever had to work on bias, on reducing the bias? Did you have a chance to do that?
Not directly. No, I can point you to the sort of usual references that you will see out there. I don't have direct experience on reducing bias for a specific project.
Okay. Cool.
All right, let me catch up with the chat. Your funniest, most interesting NLP application use case. Okay, I'll also paste it in the chat. There was a talk I gave at PyData 2, 3, 4 years ago. Okay. That's my best PyData moment. And I want to make clear, it was a joke. It was just a side project done as a joke. Next, would you say there is any added value for NLP research coming from domain-specific studies, for example, cognitive linguistics? So are there any inspirations in NLP drawn from theories about how do brain cognitive process language, meaning metaphors? One of the points that I wrote down as a talking point, in case nobody had a question, was, do we still need linguistics? Is linguistics still relevant? And the feeling is that yeah, now with deep learning, we just do deep learning and we don't care about the actual specific domain knowledge. But my feeling is that that's still important. So having either a computational linguist or somebody adjacent is still very, very important. Are there any inspirations specifically in NLP drawn from theories? I'm not sure if at the moment we are there. So there are some things, for example, in word embeddings, the linguistic inspiration comes from the 50s. The distributional hypothesis, and the idea is that words that occur in similar contexts tend to have similar meaning. So at the end of the day, word2vec is yes, it's a neural network, but we are counting words that occur together in a smart, fancy way. But that's what it is. We're counting words that occur together, and the motivation goes back to the 50s. So we have this sort of references, things that come back and forth. I'm not specifically familiar with cognitive linguistics, but definitely the whole field of linguistics and computational linguistics is very, very important, even though we often have the tendency of forgetting that there are other people working in the same field. So for me, I come from NLP with a computer science background, and my original interest was building semantic search engines. And then I realized I don't know anything about linguistics. So every time I talk to people in the field or I read papers on the topic, I learn something that is potentially useful. But yeah, specifically about the meaning, the distributional hypothesis thing, it is not about how the brain processes meaning, but it's more like how the language appears, essentially. So short answer, there's a lot going on, but specific examples are, you'll need a specialist in linguistics for a specific example, I guess. All right. Cool. I'm happy to stay for as long as you want. We have roughly 1 hour for the segment here, so I guess we're getting closer to the end. I pasted in the chat earlier my couple of contacts with social media, newsletter, and whatnot. So feel free to reach out later on. I'll be on and off during the conference as well. If you want to ping me there with your NLP questions and whatnot. Conrad, are we wrapping up?
Yeah, if anybody has any,
we still have time for a last question, for a last chat. If anybody has anything.
Yeah, please speak up or post in the chat. Otherwise, thank you, Marco. We're super happy to have had you here to give us this talk and for you to share your best PyData moment. And then hope everyone else has a great rest of the conference. Yeah,
thank you all for attending and for engaging, and hopefully this format will come back next year as well, or in any future event.